So in this video, we're going to look at how the different states of matter affect the density of any substance. So for the most part, this rule holds true. There are a few really weird exceptions. Water is actually one of those exceptions. If you've ever noticed that ice actually floats on top of liquid water, okay, it's a weird exception. Most of the time when we are dealing with density, this rule is going to hold true, and it probably makes sense. You've drawn particle models of solids, liquids, and gases before. So if we think about this, you know that solids have particles that are really, really closely packed together and have very, very little movement. We just saw that when we did our last drawings. They were all solids, so we drew them all close together. So in this case, any substance, when we are dealing with a solid, is going to be molecules or atoms that are packed very closely together. Now, if we take that same amount of substance and we turn it into a liquid, what's going to happen to those particles is they're going to start to spread out and they're going to start to move faster. If you think back to IPS, the reason this happens, right, they gain energy, they start moving faster, usually the temperature warms up. So in our liquid state, these molecules or atoms spread out. We could draw movement arrows in here to show that they're moving. You've probably done that before. Because we're dealing with density right now, I'm going to keep the movement arrows out because they're not as important to what we're talking about. But just know that if you've drawn those movement arrows in the past, that's a thing. You could draw them in there. Okay? When we take that liquid and we turn it into a gas, those particles are going to spread out even more. They're going to move even faster. Okay? So now if we think about what we've learned from density, right? Density is how much stuff fits into a given amount of space. Okay? So if we look at each of these pictures and we think this is the same amount of space, these squares are all roughly the same size, and we think about the amount of stuff that is in each one of these squares. Well, there's a lot of stuff here. There's a little bit less stuff here, and there's a lot less stuff here. Okay? So if density tells us that the more stuff there is in this amount of space, or the more atoms or molecules, the more matter there is in a given volume, the more dense something is. This would be our most dense. And this would be our least dense. Okay. Like I said, this holds true for almost all substances we deal with. There are some weird exceptions. The most common exception that you know of is water. Okay. If we think about water, it would make sense that ice would be the most dense, then liquid water, then water vapor or steam, which is the gas form of water. What we know, though, is that liquid water tends to be more dense than solid water or than ice because ice will float on top of liquid. It's an exception. It has to deal with how the atoms fit together. Okay? Just know that water is the weird exception. And for most things that we deal with, as something goes from a solid to a liquid or a liquid to gas, its density decreases because a gas is the least dense because the molecules are spread the farthest apart.